observed as the pressure increases or the temperature increases, so does the other. So it's not something that one does without the other. So if you increase the heat, the pressure will go up. If you increase the temperature, increase the pressure, the temperature will go up. Pressure scale. Let's look at it. Two different sets of letters we're going to be talking about. PSIG, pounds per square inch gauge pressure, and pounds per square inch atmospheric pressure, PSIA. Your gauge will always show at zero pressure, there's actually 14.7 pounds per square inch of pressure. That's the atmospheric pressure that we feel on the Earth. Our gauge doesn't show it, but it's still there. And the absolute pressure of PSIA, 0 PSIA equals pressure that cannot be further reduced. You cannot go below 0 atmospheric pressure. A perfect vacuum is at 0 PSIA. But we pull vacuums on PSIG, not PSIA. On your gauges are showing you PSIG. No, this is a little confusing, and you might need to look at it in your book. It's hard to describe it without more materials. Partial vacuum is any pressure below atmospheric pressure. So 14.7 or 0 PSIG is not a vacuum. That's just the absence of a vacuum, absence of pressure, except for atmospheric pressure. Once you get to 14.6, then you have a partial vacuum pulled. 14.5 is a partial vacuum pulled, but it's not a perfect vacuum. Units for pressure measurement. Pounds per square inch is usually what we use. We also use inches of mercury, feet or inches of water column, torrs, bars, atmospheres, and kilopascals. The only ones you'll use in the field is pounds per square inch and inches of mercury. Pounds per square inch is the amount of pressure on something. How many pounds of pressure are you putting on that object? And inches of mercury is the vacuum you're pulling. Here's an inches of mercury reference in a picture. Again, you're pulling a vacuum up in that tube. You've taken the air out of the tube, and the water gets sucked up there, kind of like a straw, but this has a top on it. This is what we normally pull a pressure on if you're using a gauge, is 29.92 inches of mercury, which is the bottom side of 0. It's no pressure at all. Most technicians in the field use a manometer. This manometer measures in inches of water column. So, for example, in this picture, it shows a ductwork, and you have one side of this tube that has colored liquid in it into the ductwork, and the other's outside in atmospheric pressure. You can see the blue liquid on the right-hand section of that tube that's outside the ductwork is higher, and on the left hand it's lower, because there's pressure inside the ductwork that's blowing into that tubing and pushing the blue water up. And what this is used for, it tells you how much pressure you have in your system. You need to have air conditioning pressure or nothing's going to move. So this just gives you a way to figure that out using a tube full of water. In this case, it's called a manometer, and most technicians use those to do air pressure. And it's something you should carry in your tool bucket, because it will tell you, if you can't see the evap coil, it'll tell you whether or not the evap coil is dirty. pound gauges. So they measure both positive and negative pressure. And what I'm saying here is, here's your positive pressure on PSIG, or pounds per square inch, on this gauge. The gauge will go up to clockwise and show your pounds. If it goes down from 0 or counterclockwise, it shows vacuum pressure, which is measured on a gauge in inches of mercury. Hg is the chemical sign for mercury. So it's just showing you how much it's pulling down. And again, to pull the good vacuum on a home system, to get it to 29.93 inches of mercury is great. But sometimes you can't do that. We're not going to cover Boyle's Law. This is something you can read over for your own knowledge, but it says the volume of gas varies inversely to the pressure provided and temperature of gas remains constant. And we're going to show you this in actual terms rather than in formula. Charles' Law. Gay-Lussac Law. Now, we use this picture a lot in our refrigeration PowerPoints. This is a standard refrigeration cycle. It starts at the compressor, goes to the condenser, which condenses the gas to a liquid, goes upwards to a metering device at the top, goes through the metering device, and it spits a little bit of refrigerant out at a time. That's why the pressure stays high on the right-hand side of this unit. And as it goes through its 80% liquid, 20% flash gas. As it's going through the evaporative coil, it changes to a vapor. And it changes that by accepting the heat out of the air that's blown through it. And back to the compressor. On this slide of Dalton's Law, you'll see two different containers. The one on the left has the blue molecules, which is representing refrigerant. And you can see the yellow pressure gauge with the little red arrows at a certain pressure. On the one container next to it, it has air molecules as well as refrigerant molecules. And you can see the yellow gauge is a little bit higher, the red line on it. Remember, you can only put a certain amount in these cylinders without compression. So you can change the compression of these. But in this case, what Dalton Laws tells you is when you have a state where there's mixed gases in a cylinder, you have to take the pressure of each gas to add to calculate to get a total pressure. So in this case, the addition of the air molecules actually increased the pressure of the cylinder. And why this is important on your job is that you will use refrigerants that are combined refrigerants, like 410A. That's not a single refrigerant, it's a mixed refrigerants. I don't remember which two make up the mixture. But how this plays into a leak, if you have a leak in a system, these refrigerants in 410A have two different characteristics. So in the case of a leak, you will lose the lighter volume of refrigerants. So you're just going to lose one of the two on a small leak. And if that continues to happen, sooner or later, you're not going to have a true mixture of 410A. It's going to have the heavier molecules will still be in the system. The lighter molecules will usually rise out of the system. So in this case, at a certain point, you have to remove all the 410A that's in there because it's not pure 410A at that point. Fix the leak and recharge it with 410A, which will give you a proper charge. Because if you keep adding 410A to a leaky system, sooner or later it's not going to work very well because you're losing all the lighter volume refrigerants. Saturated vapor. condition of balance on an enclosed quantity of fluids. If the heat is added or the pressure is lowered, more liquid will vaporize. If the heat is removed or the pressure increases, more vapor will condense. Basic principle that provide cooling effect. You need air exchange, pressure change, and state change. All these things have to happen to have the cooling effect happen in a confined space. Review. As a substance is heated, its volume tends to increase. Increased force will increase pressure. An increase of pressure will increase heat. If the area increases, the pressure decreases. Energy is added to a substance, volume, temperature, and pressure will increase. When gas is compressed into a smaller space, heat is added to the gas. Difference between absolute pressure and gauge pressure is 14.7 psi. The pressure below atmospheric pressure is measured in inches of mercury. Small pressures above or below atmospheric pressure is measured in inches of water column. If applied pressure on a saturated vapor is decreased, then some of the liquid will evaporate. Solids and liquids normally cannot be compressed like a vapor. Reviewed continued. Gas will expand to fill its container. When gas is at 0 psig, there is no pressure or no vacuum. A gas is a physical substance that does not have shape, and it expands to fill its container. If pressure is applied to a sealed cylinder, the pressure will equal throughout the cylinder. The high pressure and high temperature of a substance will cause physical change of state. Dalton law states, in a confined mixture of gases, the pressure of each gas must be added to calculate total pressure. According to gas law, the pressure of gas is held constant as the temperature increases and the volume increases. A saturated vapor will condense if the pressure of the vapor is increased and the temperature decreased.